Hello, my name is Tiago, and I'll present this work called Finding Concept-Specific Biases in Form Meaning Associations. This was joint work with Brian, Søren, Ryan, and Damián. So Saussure famously claimed that the association between word forms and meanings is arbitrary, and this is usually termed the arbitrariness of the sign. So for instance, we can ask, why is some specific meaning, like dog, called cachorro in Portuguese? In other words, there seems to be no clear patterns in how meanings are attached to the things, word forms are attached to the meanings they represent. But this, though, is not the whole story. Several previous work have found small but systematic patterns in how meanings and word forms connect. You have something called the systematicity of the sign that says that similar meanings are more likely than chance to have similar forms. We have phonestemes, which are submorphemic units that usually represent some kind of small semantic domain. And in English, the classic example would be gl, which is usually associated with things related to light or vision. For example, glisten and glow. And we also have iconicity, where word forms resemble their meanings directly. For instance, the word meow resembles the sound the cat makes. So in a paper published in ASJP 2019, we looked for systematicity within languages. And the main idea in that paper was to define systematicity as a mutual information. So yeah, we defined it as the mutual information shared between meanings and forms. And this can be decomposed as the difference between two entropies. The first one is the uncertainty over word forms themselves. So how many words could you roughly have picked for any meaning in the language? And then the uncertainty over forms once you know the meaning you want to convey. And this difference then will represent what meaning tells us about word forms. So how much information we get about the forms after we know the meanings. In this paper, though, we want to analyze a similar question, but cross-linguistically. So are there cross-linguistic associations between the forms and meanings of words? And obviously, we will also want to know how do we find them. So one example is that the word for tongue has been claimed to be more likely than chance to contain the phone L. And you can see in this plot some examples of languages containing this. And just for your information, this is a very biased map where I handpicked the languages. But for our analysis, we'll make use of this very cool data set called ASJP. And this is composed of a series of basic vocabulary word lists. It covers almost 3/4 of the world's languages, with 5,189 languages in it. And for each language, it will have at most 100 word forms for the same aligned basic concepts. So we have things like body parts or color terms in there. Words that should be present in at least most of the world's languages. And as our method, we'll use the same definition as before, looking for this mutual information between meanings and forms. We need to be able to compute these entropies, which is not feasible. So what we do is we use a cross entropy upper bound instead of looking at the entropy directly. And we can estimate this cross entropy using sample estimates of it if we have some kind of estimate for the word form distribution, and we model it using LSTMs. We can similarly get the entropy of a form given a meaning with another LSTM where we condition it on meaning representation. And in this work, we learned the meaning representations directly from our training set. So there's a big issue with this is that cross entropy needs to be computed on held out data from training, which means that the data we use for testing has to be independent from the one we use for training. Languages, though, have been in historical contact, and they are surely not IID. You have language families which develop together. You have geographical contact, and these things will influence the proximity of the word forms in a way that could bias our cross-entropy estimates. So to maximize the independence between our training and test set, we split our data per macro area, where you can see the 4 macro areas we used for this work here in this plot. And we use 2 of them for training, 1 for development and 1 for test. And we cross-validate across them. Well, some language families, though, may cross macro areas. And for languages in those families, we group the whole family in the macro area with more of the family's languages. And we do this because we believe that genealogical contact is more important to control for than geographical one in our analysis specifically. And we give more details of other controls that we apply in the paper if you're interested. So going forward to our results, we find that there is a very small average contribution of meaning into form. It's approximately 0.3%. And as a note, when we did this with Finn language, we found roughly 3 to 5% of the uncertainty in forms explained by the meanings. So we conclude from this experiment that there are very small but significant bias, but we draw no strong conclusions at this level of the analysis. We now move to a per concept analysis, and out of the 100 concepts, we find that 26 of them have significantly positive MI. And we find that pronouns present the highest values. Most color terms in our data show statistically positive MI, and some concepts related to body parts and the environment are also significant. We conclude from this experiment that the effect seems to be driven mostly by a subset of the concepts. We then move to a per language analysis and find that out of the roughly 5,000 languages, only 85 of them have significantly positive MI. And we note that there are at most 100 data points per language here. And this is a hard statistical test after the corrections for multiple testing. So we could take this experiment in basically 2 ways. We can think that cross-linguistic form meaning biases are potentially not as rare or weak as believed, and they are roughly distributed across languages. But that we find a few significant ones because of the chance of the experiment. The other hypothesis would be that a few languages which are more iconic or more systematic are driving this effect. And we believe that further studies are needed for stronger conclusions to differentiate between both of these ideas. The last one is a per concept token analysis. So we pick concept and token pairs with particularly large MI across all 4 of the macro areas. And we show them here. And we note that this hash symbol is used for the end of string token. So analyzing these results, we see here the association between L and tongue and between P and foo, which have been found before as well. We also find associations between M and U and the concept breast, which have been posted by previous work, and previous work suggests that this may be due to the mouth configuration of babies when they're feeding. But yeah, it's interesting that we find these associations here in our study. And finally, we find that all the pronouns in our data have a strong association with the end of string token. And this is kind of a straightforward result in some sense. It just tells us that the word forms for these concepts won't have an average length similar to the average distribution across the other word forms, which is kind of obvious since these are very frequent words across all languages. And we have Zipf's law of abbreviation that says that frequent words will be shorter on average. To conclude, we proposed a way to quantify cross-linguistic for-meaning biases, and we pointed out problems in moving from a within language analysis to a cross-linguistic setting, proposing solutions to them. We find a set of concepts with particularly high mutual information and find that these seem to drive most of the effect we find. And we find a number of stronger concept token associations. So thank you for watching our presentation, and we'll see you at the question answering or at the poster sections, hopefully. Bye.